For today's lecture, we will learn how to find the integral for sec function. As we can see here, it depends on the type of the power. If we have even power, then usually the integral will be solved by using the substitution method. And if we have odd power, then it will be usually solved by using integration by part. And before we go to the practical example, we need to mention it is possible to solve this type of integral for sec by using the integral by part regardless if the power is odd or even. We can use directly the integral by part. But it is better to follow this strategy to solve the integral for sec depending on the power type, if it is even or odd, because this is the easiest way to solve the integrals. And by solving the example, the idea and the picture, it will become more clear and clear. Let's see this example. Find the integral of the following function. Integral sec to the power 6 x dx. As we notice, we have even power. Then we will solve this integral by substitution method. How we will do that? We have even power, then we withdraw 2 from the exponent. 6 withdraw 2, it will become 4. So the integral, it will become integral sec to the power 4 multiply sec square. And this part, we need to put it to the quadratic exponent. It will become sec square all to the power 2 multiply sec square x dx. We have sec square, then we will use the sec square formula. Sec square equal 1 plus tan square, and this part we will substitute it here, and the integral will become integral 1 plus tan square all to the power 2 multiply sec square x dx. After that, we will use the substitution method. We will take this part for our assumption. U equal tan x, and we, after taking the derivative for the both sides, it will become du equal sec square x dx. Notice this value, it will be this part, sec square x dx. After that, we will put the integral in term of u, and the integral, it will become integral 1 plus tan square, it will be u square all to the power 2, and sec square x dx, it will be du. Then what we will do, after opening the square expand, we will get this result. Now the integral become easy to find the solution. We just increase 1 in the exponent and divide it to the new exponent, and we will have this result. The last step, we will put the integral in term of x, and we will get the final result. Plus, don't forget the constant number c. Let's see this example. Find the integral of the following function. Integral sec to the power 3 x dx. How we will solve it? As we notice here, we have odd power. Then the integral, it will be solved by using the integration by part. We have 3, withdraw 1, it will become 2. So the integral, it will become integral sec x multiply sec square x dx. And we will use integration by part as we learned from our previous lecture. This is the formula for the integration by part. Integral u dv equal u multiply v minus integral v du. So let's take our assumption. We will take this part for u. It will be u equal sec. With the derivation, it will become, what is the derivative for sec? It will be sec multiply tan. And dv, we will take this part for dv. dv equal sec square x dx with integration. The integral for dv, it is phi, and the integral for sec square, it will be tan. We will substitute all these values in the integral formula by parts, and we will get, and after the simplification, we will get this result, and we will call it equation number 1. As we notice here, we have remaining integral. We will try to solve this remaining integral alone. So the integral tan square x multiply sec x dx. We have already the quadratic exponent for tan, Then we will use the simplification formula, tan square equal sec square minus 1. We will take this part and we'll substitute it here. We will put it in the integral. After put it in the integral and open the bracket, we will get this result. Integral sec to the power 3x minus sec x dx. By using the integral properties, distributing the integral to the function, we will get this result. Be equal integral sec to the power 3x dx minus integral sec x. It will be equal integral sec to the power 3x dx minus, what is the integral for sec? It will be ln sec x plus tan x, and we will call this equation number 2. Notice here we have integral sec to the power 3x dx, and also in the question we need to find the integral for sec to the power 3x dx. What we will do? We will put the result integral from the equation number 2, we will put it in the equation number 1. So the integral, this is the equation number 1. After putting the result integral from equation number 2 and equation number 1, we will get this result. This is from equation number 2. And after open the bracket with the negative sign, we will get this result. Then what we will do? We will transfer this part, integral sec to the power 3x dx, we will put it in the other side. So it will be 2 integral sec to the power 3x dx equal this value. Now the integral is already solved. We just divide it on the both sides with the number 2, and we will get the final result of this equation. It is simple and easy. This is for today, and see you next lecture.